Okay, 2.5. These are all the other different types of equations that you might see in an algebra class. So we went over linear and we went over quadratics, but now these are other types of equations that you might see. So I have to give you a whole bunch of examples because there's so many different types of equations out there. So for problem number 1, if you have an absolute value problem, you know you're going to have two answers. So you need to make a little squiggle, and one is going to be x minus 5 equals 2, and the other one's going to be x minus 5. Do not change the x minus 5, but change the 2 to a negative 2. X equals 7, x equals 3. So if you get an absolute value when you're doing your homework, make sure you get two answers. Okay, just to go over this really quickly here. A linear equation is a degree 1. You only get one answer because it's degree 1. We've already did this. We did this in 2.1. We did this in 2.3, quadratics. Quadratics is degree 2, and there are two answers because it's the degree 2. I also graph them. X equals 2 is a vertical line, and there's only one answer because it's where it crosses the x-axis. That's what you're finding, where it crosses the x-axis. For this one, it crosses at a negative 2 and a negative 1, and it looks like that. We're not asking you to graph them today, I'm just telling you. And x to the 3, since that's the highest degree, you're going to have 3 answers. And you get that by taking out the GCF and then factoring it again. So x equals 0 is one answer, x equals 1 is another answer, and x equals 1 is another answer. The highest degree tells you how many solutions there are. So on the next page, I'm not going to graph it. We're learning how to graph it in chapter 5, I think, so don't worry about graphing them right now. Okay, 15x to the 5th minus 20x to the 4th equals 6x to the 3rd minus 8x to the 2nd. There are going to be 5 answers for this problem because the highest degree is 5. Remember, you cannot factor unless you bring everything over to one side. You have to bring everything over to one side before you can factor. Okay, how many terms do we have? We have 4 terms, but before we do the 4 terms, we have to take out the greatest common factor, and the greatest common factor is x to the 2nd. You're going to be left with 15x to the 3rd minus 20x to the 2nd minus 6x plus 8 equals 0. I'm going to factor this, and we learned how to factor when there's 4 terms in chapter 1. You have to group the first 2 and group the second 2. Take out the greatest common factor in the first 2, which is 5x to the 2nd. When you take a 5x to the 2nd out of 15x to the 3rd, you get 3x minus 4. If you take out negative 2 out of these two, remember that this is a negative 6x, so that needs to be 3x, and this also needs to be a negative 4. And I check it to see if I did it right. If I took a negative 2 out, I check it. That's a negative 6x. That's a positive 8 equals 0. Okay, keep going. We know we have an x squared, and we know that these two groups have a 3x minus 4 in common. If you take a 3x minus 4 out of this group right here, I'm underlining it, you're going to have a 5x squared minus, if you take a 3x minus 4 out of this group, you're going to have a negative 2 left. I just want to go back to the last page really quick. I kind of explained to you when we do quadratics that you take the 2 and you break it down into the 1 so that you can solve the problem. If you have 3 answers, you want to break it down so that you can solve the 3. And do you see what I did? I broke it down into 1s. Do you see that? So that's kind of what we're doing. We're slowly breaking down x to the 5th. Well, so far I have an x to the 2nd, I have an x to the 1st, and I have a 5x to the 2nd. That's good. There are 5 answers hiding in there. X squared times x equals 0. X has to equal 0, but you can have 2 zeros because you have it to the 2nd power. So those are 2 of the answers. We still have 3 more. Here's another answer, 3x minus 4 equals 0, so x equals 4/3. That's a 3rd answer. And the other 2 are hiding in here, 5x squared minus 2 equals 0. Does not have a middle term, so you have to add 2 to both sides. You have to divide by 5. You know that there's 2 answers. All I'm going to do is square root and square root. X is going to equal plus or minus. Don't forget the plus or minus. That's where the 2 answers come up. That's right. I can split this up into the square root of 2 over the square root of 5. I can't leave a radical in the denominator, so I have to multiply the top and the bottom by the square root of 5. X equals plus or minus square root of 10 over 5. Remember, the highest power in this problem was x to the 5th. There's 2 answers here. There's 1 answer here. And there's 2 answers here. Okay, the next one. Again, these are all different types of equations that are not linear or quadratic. These are absolutes, x to the 5th power. Now, for the next couple of problems, we're going to do radicals. Whenever you do radicals, I'm going to write it up here, you need to check. Make sure you check your answers whenever you see a radical on your paper, on the test, on the ACT. So in order to do radicals, you want to get the radical alone. So I'm going to add x to both sides. I added x to both sides of the problem. Now that I added x to both sides of the problem, I'm going to square both sides of my problem. Take this side and square it, and this side and square it. If you take the square root of something squared, they negate each other, so it'd just be a 3 minus x on the left-hand side. Okay, this is my pet peeve move in college algebra. If I asked you what x plus 3 squared is, you need to write out x plus 3 twice and do the FOIL method to get x squared plus 6x plus 9. If you don't write it out and you leave it as x plus 3 squared, some kids are going to just square this, and they're going to square this, and they think it's this, but you're missing the middle term if you don't write it out twice. You cannot factor until you bring everything together on one side. So x squared plus 7x plus 6. I added x and subtracted 3 and got x squared plus 7x plus 6. Now I'm going to factor it. X plus 6, x plus 1, x equals a negative 6, x equals a negative 1. Once you are done solving a radical equation, go back up to the top. Radicals must be checked. So my two answers were a -6 and a -1. I'm going to go back up into here. I'm going to go back up into here, the beginning. Remember my answers. I had a -6 and a -1 were my two answers. Let's put in a -6 in for x. I'm going to come down here and do the square root of 3 minus a -6 minus a -6. And that needs to equal 3 if -6 is true. Two negatives equal a positive. 3 plus 6 is the square root of 9 plus 6 equals 3. Square root of 9 is 3 plus 6 does not equal 3. 9 does not equal 3. -6 is not one of the answers to the problem. Let's check the other one. The square root of 3 minus, in place of x, a -1, minus a -1 again, equals 3. This ends up being the square root of 4 plus 1 equals 3. The square root of 4 is 2, and 2 plus 1 equals 3. Yes, a -1 works into that radical. So the only answer to this problem is a -1, because I checked my work. Okay, the next one. Y raised to the 4/3 power is equal to a -3y. So you could do this two different ways. I am going to leave the y to the 4/3 and bring the 3y over to the left side. I brought the 3y over to the left side, and you're going like, what am I going to do now? I've got y to the 4/3 plus 3y equals 0. They have a greatest common factor, and the greatest common factor is y. I'm going to do this part first. This ends up being a 3 right there if you take a y out of the second one. Okay, now I'm going to talk about the y to the 4/3. 4/3, you guys, is the same thing as 1 and 1/3, correct? 1 and 1/3. If I take out y to the first, I'm still going to have, if I took out the 1 part, I'm still going to have the 1/3 in there. So I have y to the first and y to the 1/3 plus 3 equals 0. Y equals 0 is going to be one answer to the problem. The other answer is going to be y to the 1/3 plus 3 equals 0. Chapter 1, you learn that you can change an exponent into a radical. That's the same thing as the cube root of y. Y raised to the 1/3 is the same thing as the cube root of y equals a -3. And all you have to do is, if you want to get rid of the cube, you have to cube both sides. So y is equal to a -3 times a -3 times a -3, which is a -27. When you plug 0 back up into the problem, 0 to the 4/3 equals a -3 times 0. If you plug 0 here and 0 here, it equals 0 equals 0. So that's true. So this one works. And if you plug a -27 up there, let's check it really fast. A -27 raised to the 4/3 power equals a -3 times a -27. Well, I can do the right side quickly. That makes a +81. A -27 is the same thing as a -3 to the 3rd raised to the 4/3. Base numbers. Goodbye to the 3's. A negative 3 times itself 4 times is 81 equals 81. So I can keep both of my answers. I can keep both of my answers. Okay, we just did square roots, cube roots. Let's do another cube root. The cube root of 6 minus x. I'm going to rewrite it. I don't like the way the smartboard did that. And when I rewrite it, I'm going to get the radical alone and bring the 5 over to the right-hand side. If you think I'm going too fast, you can always stop the video and rewind it. This assignment is a lot of different types of equations, so you might want to stop it and restart it. So, okay, all I did was subtract 5 to both sides. Notice that the radical is alone. Instead of squaring both sides, I'm going to cube both sides of my problem. The cube root and the cube negate each other, so you're left with 6 minus x squared is equal to. And if you don't know what a negative 5 to the third power is, use your calculator, but it ends up being a negative 125. You do not bring everything over to one side because it's missing the middle term, and when you're missing the middle term, you want to get x squared alone. I'm going to subtract 6. That makes a negative 131 when I subtract 6 to both sides. They both have a negative sign, so I can cancel those two out. How do I get x squared equals to 131? All I do is square root both sides. But whenever you square root in math, don't forget the plus and the minus. I remember this problem from last year. The square root of 131 is in reduced form. You have to leave it as the square root of 31. Plus or minus the square root of 131. Okay, the next one. You're going to see one like this on the test, so you have to know how to do this. When you see a radical, the first thing you want to do is to get it alone. Another thing you have to remember on the test is to check your answers after you've finished. So by getting the radical alone, I am going to get rid of this by bringing it over to this side, and I'm going to bring this over to that side. That way I'm going to get rid of my negative sign. So if I brought the negative 2 over, it's going to end up being a plus 2. And if there's a negative in front of the radical, I'm going to add that to the other side. I think that's the easiest way to get rid of the negative sign in front of the radical. We have the radical alone. Everybody see that? We have the radical alone. We're going to square both sides of the problem. And when you square, you get a negative 7x minus 24. And here comes my x plus 2 squared. I did one like this a couple of problems ago. Remember, it's x plus 2 and x plus 2, which really makes x squared plus 4x plus 4. You have to bring everything over to one side. X squared plus, I'm bringing him over to join the 4x. That makes 11x. I bring the negative 24 over to join the 4. That makes 28 equals 0. We need to figure out factors of 28. That will give us 11 in the middle. And a lot of you know what the factors of 28 are. That will give you 11 in the middle. X plus 4 and x plus 7 equals 0. X equals a negative 4. X equals a negative 7. But you got to remember, you have to check your two answers up into the original problem. Check your answers. The answers, remember, were a negative 4 and a negative 7 were my two answers. So here I go. In place of x, I put a negative 4 minus the square root of a negative 7 times a negative 4 minus 24 needs to equal a negative 2. So in place of all the x's, which there's only 2 of them, I put a negative 4. A negative 4 minus the square root, this makes 28 minus 24 equals a negative 2. Negative 4 minus 28, take away 24 makes 4. The square root of 4 is 2. A negative 4 and a negative 2 does not make a negative 2. Negative 4 is not one of the answers. Do the same thing with the negative 7. A negative 7 minus the square root of a negative 7 times a negative 7 minus 24, and see if it's equal to a negative 2. Negative 7 minus the square root, 2 negatives equal a positive, so it's 49 minus 24 equals a negative 2. Negative 7 minus the square root of 49, take away 24 is 25. A negative 7 minus 5. A negative 7 minus 5 does not equal a negative 2. So after all of this one doesn't work, and this one doesn't work. This is a no solution. You have to check your work. And this one right here will do the first two, but I'm not going to do the last two. Again, what happens if it's an exponential form? This got into logarithms. But in order to get rid of 3/5 on this side, all I do is raise both sides to the 5/3 power. Whatever you do to one side, do to the other. These are reciprocals of each other, so that's why it's an x. But how do you do 27 to the 5/3 power without a calculator? You change 27 to 3 to the 3rd raised to the 5/3. The 3's cancel out, and 3 to the 5th is, I think, 243, not 81. Same thing with this one. You want to get x alone. You're going to raise both sides to the 2/3 power. X equals, change 8 to 2 to the 3rd is the same thing as 8 raised to the 2/3. Goodbye to the 3's. X is equal to 4. Okay, I think we're on the last problem of the notes. What happens when you have a radical inside a radical? Well, it's kind of hard to separate them. The best you could do is just start squaring both sides of your problem. That's the best you can do. And I think, again, number 8 might be on the test, very similar to it. I'm going to do the right-hand side. You're going to get 3x minus 5 left on the right-hand side. On the left-hand side, the only thing, see how this square root and this 2 cancel each other out? Well, this 2 and this cancel each other out. So you're still left inside the radical. You still have a 2 and you still have an x plus 1 left. Okay, get the radical alone by dividing both sides by 2. So I'm getting the radical alone, and after you get the radical alone, you can square both sides. You're going to get x plus 1 on the left-hand side Just like you do a radical, you can break this up into 3x minus 5 squared over 2 squared. You can break this up. So 2 squared is 4. The denominator is going to be 4. Remember, 3x minus 5 is 3x minus 5 twice. And if you can't see it, write it down. And you're going to get 9x squared minus 30x plus 25. There's supposed to be 5 at the end. I'm going to get rid of this fraction by multiplying both sides by 4. 4x plus 4 equals 9x squared minus 30x plus 25. Bring everything over to one side. 0 equals 9x squared minus 34 x's plus 21. I brought everything over to one side. Factor it. Um, 21, I'm going to try 7 and 3. And 9. Well, 21 is 7 and 3. I'm going to try 9 being the 3 and the 3. And that's 21 and 9 makes 30. So it's not the 3 and the 3. The 3 and the 3 does not work. I'm going to put the 9 here and the 1x here. And it does. This makes 27. This makes 7. 27 and 7 adds up to 34. They both need to be negative in order to make a positive 21. X equals 3 and x equals 7/9. But remember, there's a radical, so you have to check your work. So when you plug a 3 up into the original, it's going to be the radical of 2 with the radical of x plus 3 equals the radical of 3 times 3 minus 5. And then when you work this out, this was supposed to have been 3 plus 1, sorry. 3 plus 1 is 4. The square root of 4 is 2. So now we have the square root of 4 has to equal 9 minus 5, which is the square root of 4. Does the square root of 4 equal the square root of 4? Yes. X equals 3 works. Let's do the next one. 7/9. This one isn't as easy. Come over here and do 2 plus a radical of 7/9 plus 1. This has to equal 3 times 7/9 minus 5. 7/3 minus 5. This is going to end up being an imaginary number. This is going to end up being a irrational number. There's no way that they're going to equal each other. Without even finishing the problem, you cannot keep 7/9 as your answer. So there you go. Those are the notes for 2.5.